Hello everyone, hope all of you are safe and doing well. I welcome you all to my YouTube channel Ankuram. This is my first video lecture on digital signal processing. I am Aishwarya, Assistant Professor ECE Department working in RMK College of Engineering and Technology. So before going into deep concepts of digital signal processing, let us first brush up some of the basic terminologies that is associated with the subject. So let us define or recollect what is meant by a signal, what are all the classification of signals, why we opt digital signal, how to process a digital signal, and what are the career opportunities that is available to study DSP. So first let us define what is meant by a signal. Signal is something which conveys information about a phenomena. So here we hear an audio signal from the speaker or from my mobile phone. This is a sound signal. Here we can see a person who is turning off the fire. As a result, smoke is emitted into the clouds, which is nothing but a smoke signal. Here is a person who is doing hand gestures. All actions are also considered as signals. Here you can see a railway track where a red signal indicates that we have to stop until the train is getting crossed. Another signal is an ECG signal which tells us the activity of a heart. And finally, here are the neurons which is communicating with each other by transmitting electrical pulses. In our everyday life, we come across many types of signals. So signal is nothing but an image, an audio, or it can be a video, it can be an object, or it can be gestures. So technically speaking, signal is a function of time, space, or any other independent variable which conveys information. So here is an example of a speech signal or voice signal which is defined for every value of time t. So in this subject, we are going to consider the x-axis as time and the y-axis as amplitude. Now we will see the classification of signals. Signals are categorized into 4 types. First one is continuous time, continuous valued signal. As the name continuous indicates, the values are defined for infinite set of values, which means the values are uncountable. Here is a simple example for continuous time, continuous valued signal. See here, for every time instant t, we are defining an amplitude. Here, the time instant t is defined from 0 to infinity, as well as the amplitude is also defined from 0 to infinity. So, both have infinite set of values. And the next category is discrete time continuous valued signal. So, instead of taking infinite set of values at x-axis, which is nothing but our time, we are going to have only limited set of values which results in faithful reproduction of this signal. So let us see that signal. Now you can see that instead of having infinite set of values, we have taken only limited values where we have reconstructed the signal efficiently. So the continuous time signal is getting converted to a discrete time signal. This process is called sampling. And the next category is continuous time discrete valued signal. So here, as the name indicates, the time will have infinite set of values. However, the amplitude will have only finite values. So let us take a continuous time continuous valued signal. See how it is getting converted to discrete valued signal. So instead of defining all the values in the amplitude, we are going to have only specific set of values. This discrete valued signal is nothing but the integers of this continuous valued signal. Say for example, if I have an amplitude of 0.1, then it will be marked at 0. Suppose if I have an amplitude of 1.5, it will be taken to 2. Like that, we will be defining for every time instant. And the last category is discrete time discrete valued signal. So here is Another example for discrete time discrete value signal. Here both the x-axis and the y-axis are defined for finite set of values. How can I get this signal from this continuous time discrete valued signal? By the process called quantization. If we round off the amplitude value, it is called as quantization. If we take the finite set of values at x-axis, which is nothing but our time, it is called as sampling. So don't forget the terms sampling and quantization. I again repeat, sampling is the process of converting the continuous time into discrete time, whereas quantization refers to converting a continuous valued signal to a discrete valued signal. From the classification of signals, now we will define what are analog, discrete and digital signals. All the continuous time, continuous valued signals are analog signals. All the real world signals are analog signals. All the discrete time, continuous valued signals are called as discrete signals. How we can obtain a continuous time signal from, how we can obtain a discrete time signal from a continuous time signal? By a process called sampling. All the discrete time discrete valued signal are called as digital signal. How can we obtain a digital signal from a discrete signal? By a process called quantization. So this is a block diagram which shows the conversion of an analog signal to a digital signal. Now we will discuss why we have to go for digital signals. All the natural signals are analog in nature, correct? Then don't you think it's waste of time and resources for such conversion process? Here are some of the advantages that why we opt digital signals. First advantage is easy transmission. When an analog signal is transmitted over a long distance, the signal level may be attenuated and the signal can be combined with the interference from other sources. As a result, the signal may be lost or it cannot be faithfully reproduced at the receiver. However, digital signals are purely dealing with numbers, which is nothing but zeros and ones. So, even when the signal is getting corrupted by an external source, the signal can be easily reproduced at the receiver end. Obviously, digital signals have less storage capacity as compared to analog signal. As I said, digital signals have numbers, which is nothing but zeros and ones. And the third advantage is immune to noise. Even when the digital signal is corrupted, it can be cleaned up easily. And the fourth one is highly secure. We can encrypt the digital signal, but this provision is not provided in terms of analog signal. Obviously, the speed of transmission will be high for digital signals when compared to analog signals. Next one is high accuracy, which means the amount of uncertainty is very less. That indicates the transmitted signal can be perfectly reconstructed at the receiver end. Last one is digital signals are more economical. The utility of spectrum, which determines the cost, will be very less when you opt digital signals. So with these advantages, now let us see how to process digital signals. The first block indicates an A to D converter which converts an analog input signal to a digital output signal, and this is a processor which will process the digital input depending upon the application, and again the signal is getting converted to analog and then it will be fed to the specific application. Now this is a simple example of how an audio signal is getting processed. This is an input audio signal which is a continuous signal. Now it will be converted to numbers via ADC. The signal gets processed, and after that again the signal gets converted to analog one and fed into speaker. Now I will say what are all the career opportunities that is available for a DSP engineer. Unlike other field of study, DSP has lot of opportunities in finance sector, in healthcare, in military, wireless industry and so on. So DSP basically has two facets. One is hardware design, another one is software algorithm and applications. Suppose if you are interested in hardware design, then these are the top companies which provide greater opportunities. Texas Instruments, Intel, Samsung, Analog Devices. Suppose if you are more interested in your coding area, then you can become a space scientist in ISRO, NASA, SpaceX, or you can become a defense engineer. Even you can become a machine learning engineer or computer vision engineer. All you need is you should be very confident in your coding area, and most of these areas or organizations, they expect to be they expect you to be well versed in C, C++ and MATLAB. I thank all of you for patiently listening to my video lecture. Feel free to post the queries or comments in the drop box. Stay safe, stay connected, take care.